Yo, yo, real quick, real quick, let's see how long this is, but back here to share some fine tuning on a super network. I'm trying to make this as clear as possible. It's a large language model. It's used to estimate prices based on facial descriptions. And share my screen. Um, so basically, this is from the course I'm taking. We've done data preparation. So now we're going to fine tune the model. So this, okay, so we'll go line by line. So this helps to evaluate how well our model performs. It's like a grading tool. So this basically grades our data. So it's like if you were a teacher and you have grades, so we'll put it on a scale. So test it. It's just loads of API keys, OpenAI keys. Could use this one. I haven't been using it because it costs and I don't want to keep running the code. I was just setting it up. So this logs into Hugging Face where there are several coding models, OpenAI models, ChatGPT models. There's a bunch of different models that people can look at. For example, this one, tokenizer, large language model with parameters, reasoning, coding tasks, agentic intelligence, the base that instructs with two different kinds, two variants, forecast size. These are the results. Instructional evaluations. This is for this specific one. Human instruct. There's different ones. Models. You can go by tasks, libraries, languages, licenses. Full text search trending. Let's go with trending. That one's trending. 171,000. This one's 273,000 downloads. I go sound reasoning and reasoning. Parameters. Prep install it. Can see this. Add this link to the description. I'll just turn off this video. Oh, type function. Okay, so type the code to show me what the Hugging Face is. So that's okay. Add the tokens, OpenAI, OpenAI. Open, train pickle, a DS file, train pickle, reload the file. pre-processing the data that's pre-processed. So Pickle will use the file Python instead of your machine. So these files are created after cleaning up the data and the preparation. So instead of cleaning the data again, we're just opening that data. So with test pickle, it's data that's already, we're loading that file in as a pickle. It's like, this is basically inserting the Python file, brings it back to life. So these files, they're like non-human, so it would be a little bit more difficult to read. So if you open a typical file that's not trusted, it can be dangerous, you could say. That's that. And then this one, it's just training 500. You could do more. This is what we get 100. So I did it for fine-tuning JSON. So the kind of data define messages for the paradigm system messages and classes of items. So this function is crafting constraint structure for each training example. So for each instance we trained data for, we are so this is structure, different classes of items, to be dollar, such as returning the price as formation stated. Prepare some input text line, minimum price, turns the list, set up instructions, user input product description, assistant, expected true price. So this is important in fine-tuning. Fine-tuning, this step here is important because it teaches the conversation you want to have. So with the model, you teach it different ways. And if you're specific on what you want as output from the beginning, it'll save you time. So each example in the model, it needs to know what kind of conversation it needs to have. Output. So this is why it's set up like this. So role, system content, system message. Then you have the role, the user, content, user prompt, role, assistant, content, price. Okay, my system's being slow for some reason. What this function does, takes in a list of items and turns them into a single text string. So it takes a list of items and returns them in a single text string. Each example follows one. breakdown. So initial registry code collect all lines. So this will collect all lines in this, I believe. So it's in all lines like that. So this for each item in items data set, this generic instruction message, this student message. Got it. So this line, let's just be soon. Let's be close. Manually wrap that message with another JSON object. So manual result equals, so this converts the Python list of dictionaries into a JSON string. So this JSON dumps messages, so messages from here, the function we defined earlier, with result, the messages. So as a result, we want to wrap the messages in a JSON object and then add a new line. This will add a new line, this section here, and this. And the final true new line and return the full string. So return the full line, the final trailing line, full string, by this full notation to Python separates, concatenates these messages into one file. So this one, only right JSON district functional step to prepare your data for fine-tuning with OpenAI. What this function does. This function saves a data set in the correct format. So after we get this printed, so it'll write the file on the disk of your system. Items, it listed the items like this item class. So item, the name of the output, with open file name, the opens the file in write mode, opens the file with open file name in write mode, as F uses with blocker safe automatic file closing with open file name, write as F. JSON make JSON items, JSON make underscore JSON calls your previously defined JSON function to turn a list of items into a properly formatted string. Writes JSON file to a string, opens the file in write mode, converts your training data set. So this converts your training data set items into JSON, converts your training into JSON format, and this saves the data into JSON for upload, and then this JSON fine tune the training. And this is our training. This is our data set that we're training. So this one that we write, JSON, so the output from this that we're fine tuning is the disk. Um, calls write JSON function passes in function list of your first 500 curated training examples. So the training examples that we created up above So the file name that we need here, so the form, okay, ready to open, then we upload it to OpenAI. So this data set we send it to OpenAI. And when the data in OpenAI is expected structure, we need to see it as a JSON file. It's not really exactly that. We take our training samples, format them as a mental file, and training, we'll upload this file to OpenAI next for fine tuning. So this is where we write this fine tuning. This page for fine tuning. Fine tuning starts there. We should just let's look at fine tuning. Previously saved train file. So this line with open opens previously saved training file, uploads it to OpenAI using OpenAI Python SDK. Store shell reference as train file, which will be used to mount the fine tuning job with open fine tune training that JSON RBSF opens a file in read binary mode, which is required by the OpenAI SDK. F is a file object being passed to OpenAI read binary mode. So with ChatGPT OpenAI, our trained data set, we want to open it as a binary read, and we want to open it as F being this object being passed as F. So we're passing this as F, which passing this binary code to ChatGPT, OpenAI, train file, train file. This is like dragging and dropping. So this is like dragging and dropping OpenAI dashboard, but programmatically. Once uploaded, we'll use a return file ID to start the fine tuning job, and then train file now. So the train file now contains ID, a unique identifier, file name, and status. Whether this processed successfully, you'll pass the trained file .id to your fine tuning job. So fine tune OpenAI files train Dean's file F. I'd like to highlight this piece. I gotta write down some um, so I mean, I'll leave it at that. So a quick summary from what we just went through. So we loaded pre-processed data, the clean circle, prompt response pairs. So we created the prompt and how we wanted to respond and how we wanted to be created because we called the API from OpenAI for it to be a clear example. And then we converted this into a JSON file. Our examples to JSON format. and we save the JSON file to the disk. So JSON file to the disk, right? JSON saves the format is so it can be uploaded to OpenAI, uploaded training to OpenAI server, start the fine tuning, tracking through the fine tuning model, test the fine tuning model, and we can, and then we validate. Retrieve it, and then that's pretty